Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore that how a small language model, can really perform well, mainly for RAG implementation. And the other aspect of this video will also cover how domain-specific embeddings model are better when you compare this with general-purpose embeddings model. So we are going to implement a RAG in this video on the smaller models and the domain specific models that you can run it on a compute limited hardwares, right? For example, if you have a single GPU or if you don't have any GPU, you have a CPU machine, and how you can use this smaller LLMs, right? The smaller language model, I'll not call it LLMs now. So the smaller language models, when I say smaller, don't think that it's a 200 million parameters or 300 million parameters. That's not going to work at this moment, but probably 1 billion or 2 billion, right? So scale has to be on more than 1 billion right now. Language model which is probably more than 1 million, 1 billion, excuse me, has performed better, and that's what we have seen. But there are some exceptions. For example, Lamini, with 768 or something, has performed better for summarization kind of a task, right? But in this, I'm gonna particularly look at LLMWare. So if you look at on my screen, this is the demo that we are going to build, insurance RAG demo. So it's for insurance industry, and here we are going to use inference-based embedding model that LLMware has created. So LLMware is an organization who is contributing really good in the open source community, right? If you look at here on the Hugging Face, you'll find out LLMware company, LLMware AI. They have a GitHub repository as well that I will give the link in description, and they're doing good, by the way. They have 20 models in open source, mostly with Apache 2.0 license, so you can commercially use it. And they also have a data set that you can use, right? So they have an instruction RAG benchmark data set that you can use to evaluate your other RAGs that you are building, and some models and some industry specific models as well. For example, if you look at BERT contracts, the BERT-based models, by the way, the BERT-based embeddings model that will help you extract features, which is the first part of your RAG implementation, where you look at the retriever part using an embedding model. Now they have BERT SEC, they have BERT asset management, they have BERT insurance. Now you can ask this question, that why are we going to use this model? Why not use a general purpose model, right? I think, see, there are a lot of trade-offs when you work with RAG, and I think these are the things that you should know, right? It's easy to build RAG. It's very easy. 2 lines of code, you build RAG, right? But when you work for an organization, for an enterprise, there are a hell lot of things are involved. Cost being one factor, the security and compliance being the other factors. Not everybody will use closed source model. A few of the organization would like to use open source, everything on premise within their infrastructure and network. So if you work for those kind of organization, this video is helpful. If you work for like some hobby projects, pet projects, then you don't watch this video. I will recommend, don't waste your time watching this video of mine, right? So this video is important to understand that what are the requirement when you work for an enterprise, right? You have to look at domain specific model that will help build better retriever, then use smaller models that is very particular, that will be used particularly for a use case, very specific use case, like asset management or underwriting the risk, etc., right? So these are the things that I'm going to cover in this video. And if you look at here, they have Dragon models, LLMware, Dragon, Rate Pajama, Dragon, Stable LM, language model 7B. So these are the 7B model. There's one is a 6B model, and the other is a Deshi 6B version 0, right? So these are the Dragon model. Then they have BLING models, and I'm going to cover BLING. I'm going to cover this Llama shared sharded model. I'm not sure what shared means, by the way, but sharded I understand. Okay, so BLING, I think, which is an acronym for, I don't know, I forgot the acronym. There's something related to best little instruction following no GPU required, which is really intuitive and funny as well, right? Best little instruction following no GPU required. So it says that you don't need GPU to inference this model or use this model, right? This is what we're gonna look at here. Let me just ask this question, but I don't know after running it. Let me see if I'm running it. Yes, I'm running it. I've asked a question, what is group life insurance? And you can see it says generating response, and you can see I got my answer. This was your query. What is group life insurance? And then you say, okay, group life insurance is a type of insurance, that is sold to businesses that want to provide life insurance for their employees. Group life insurance can also be sold to association, blah blah blah. And then we have top two documents at top K, which is equals to, and you can see it gets it right. Most group contracts and group life insurance can be hold, and this is the document, by the way, guys, we are using. So we're going to use this document to as a source document, and you're going to create a vector store out of this. And you can see it says glossary of common insurance terms. Okay, now this is like a terms terminologies of insurance terminologies that we use, right? This is what it is. We're going to cover this embedding model, industry bird insurance. Okay, it's by LLMWare again. You can see what they say. It says it's a part of series of industry fine-tuned sentence transformer embedding model. It says a domain fine-tuned. I already have covered in my Meditron video. I'll give the link in description where I have used PubMed BERT, right, which is a medical embedding model. And has performed better than general purpose model, and they are smaller in size as well. Now you see it says a domain fine-tuned BERT-based 768 dimensions as a 768 parameter sentence transformer model intended to as a drop-in substitute for embeddings in the insurance industry domain. Fantastic, right? It's available documents on the industry insurance industry. When you work with deep learning or natural language, right, it's all boils down to weights, right? When you fine-tune this model, on particular databases like insurance in a domain or industry, the model understands the taxonomy better than a general purpose model if the general purpose model has lesser corpus when you compare with a domain specific model. And that is why it's very important, because it all boils down to weights. The weights, there will be some weights assigned to these keywords, which is more domain specific. And once you use this in your similar use cases, the vectors will be very similar. Okay, they will understand, the model will understand, okay, the search has been, uh, the search has been that been done on this vector, so let me return a similar vectors, right? So this is very important. Now let's start building this app, insurance rag demo, that you see is going to go build a Streamlit application using LLMware model. You can see it's a 1.3 billion model of llama, and we have llama 7 billion, and you can find out this is fantastic, right? More than 80%, right, size reduction. So 80% of lesser size when it comes to the params as well, and also with the compute memory, right? And that's why you can easily deploy it, and even you can inference it on a CPU machine. So let's start building this. We'll combine both the LLMware models today. One is for embedding model of the BERT insurance, and the other one is the LLM Bling's seared llama 1.3. Let's start building this, guys. All right, so to build this application, the RAG implementation that we're going to do with LLMware embedding models and the LLM, what we're going to do is create a folder first. You can see I have something called domain specific demo. I'm going to open this in terminal, and you can see I already have a virtual environment. I will show you how I created it. If you have Anaconda, you can use that. And if you want to create, you can do something like python -m venv.venv, and you hit enter, and it will create a venv for you. You can use some other ways of creating as well using virtual env as well, right? So that's how you do it. Let me activate. This is how you activate on PowerShell scripts, and then /activate. If you are on Linux, you have to do go to bin, not scripts, and then you do source activate. Let me just do a couple of cd dot, clean this and open this in VS Code. Once I open this in VS Code, I'll explain a few things here. Uh, and by the way, you can see that I'm using Hugging Face API token. Of course, I will delete this after the video. The reason is I'm using the inference API from Hugging Face to use the language model. I'll show that in a bit. But let me first create something called ingest.py. Now, once I create ingest.py, here I will write all the code for creating the vector store using an embedding model, which is the domain-specific embedding model of LLMware. Now, you can look at I have a one single file. You can keep multiple files depending on if you want to, if you have, like if your document store is too big or your database is too big, then you probably need a vector database, not a vector store. ChromaDB FAS is like they're not that good when it comes to build implementing solutions at scale. Okay, you have to look at Waviate, Qdrant, Milvus, Pinecone, and etc. Right? There are a lot of others. Now, in the ingest.py, the first thing that you have to do is you have to install all of those things. torch, sentence transformers, Streamlit, LangChain, ChromaDB, PyPDF, Hugging Face Hub, and Python.env. This will be available on my GitHub repository, so don't have to worry about it. Now, the next thing is on ingest.py. Let me just do a few things. Import OS. I don't know if I need it. Then from LangChain dot text splitter, import recursive character text splitter. I'm going to use recursive character uh, text splitter or whatever. Okay. Let me just do that. And the next is document loader. I need a document loader. So from LangChain dot document loader, because I have my data in a directory. So document loaders import. If you have unstructured data, I recommend you use unstructured library. Just go to my RAG playlist. I have more than 25 videos on RAG. Go through all of the videos and you'll be a RAG expert. Okay, so import directory loader, directory loaders. Okay, not loaders. Now these are fine. The next is from LangChain dot vector store. Uh, import, what I'm going to do is import chroma from langchain.embeddings, right? So for that, I'm going to have, now here I'm not going to use Hugging Face embedding. I'm going to use sentence transformer embeddings. I'm going to use this embedding model through sentence transformer. So let's do that. So for that, I'm going to do import a sentence transformer embeddings. This is what I'm going to do. Fine. Now the vector store chroma is done. The document loader, directory loader is done. And then we need PyPDF, guys. There is a PDF file. So from langchain dot again, right? For that also document loaders. Let me just get it after directory loader only. Okay, no need to write something new, right? Here I'm going to use PyPDF loader. Let me just do a print and see if I am able to load it successfully. Loaded, something like this. Okay, if this print message gets printed in this, you have done it right. Python ingest.py loaded, right? Let's remove that. Our import is successful. Now the next thing is to have this embedding model. So let me just do that. Embeddings equals, and I'm going to use sentence transformer embeddings, and in this you have to pass your this thingy, this Hugging Face link, of the embedding model, the insurance is domain specific embedding model. Let's do it here, and then you have your embeddings thingy done. Now let's just print the embeddings if you want to look at the pipeline of this embedding model. Okay, now print embeddings. The next is we need a loader variable to load the file. So directory loader thing, and then I have my folder as a data, and I will just close the data. Okay, now data, and then I'm looking at globe, and globe is like I have to define a PDF thingy here. So where are a couple of stars, and then uh, dot pdf. If you have csv, if you have word, you have docx, doc, whatever, you have to define like that. That's a better way of doing it. Let's do show progress to track this in terminal. So show progress equals to true, and then I'm gonna have a loader class. I want the directory loader thing to use pypdf library to extract the load and extract the data. So the loader cls, and excuse me, this underscore loader cls equals, that becomes your pypdf thingy. So pypdf loader, you can also use pypdf itself, it's fine. Loader is done. Now let's use the documents variable. Pretty much you go on langchain documentation, you'll find this loader.load. Once you load, you are done. You are have to define a text splitter with some chunking strategies, very simple chunking strategies. It's like trial and error. You have to keep trying it and see which chunking strategies work good for you. Now chunking, no, not chunking, chunk size. Chunk size, let's keep it around, I don't know, maybe 700. Okay, and chunk overlap. For how many chunk it should overlap, let's keep it 70. 1/10, I always keep 1/10 of the chunk size. Now once that is done, let's do a text equal text splitter dot split documents. It's a method, documents, and this will and let's pass your documents. This is fine. Now we are done with that. Whew. After that, let's do a print thingy here. Print text or something like this. I don't know. We'll check it out. Okay, now the next is let's have a vector store. Vector stores. And here I'm going to use Chroma, but you can use any other as well. Chroma dot from documents and then you pass your text, you pass your embeddings thingy, and I'm also going to define a collection metadata, or I'm creating the supports, IP dot Levenstein cosine blah blah blah, right? So you can look at, I have explained that in my previous videos a lot. I'll recommend you to watch that if you have some time. HNSW and then HNSW, it would be in the same one here. HNSW and then space. Now I'm saying, okay, you use HNSW, and then it should be nothing but your cosine. I want to use cosine similarity here. Okay, now cosine, and then after you do cosine, let me do an Alt G. I'm also going to persist this on my memory, so on disk. So let's do persist directory, because I don't want to create embeddings on runtime, right? I want to persist that. Okay, so persist directory equals, then you have your stores, and then you have your, let's call it a name, right? Let's create a folder and it will just create a something here. Okay, so cosine, blah, blah, blah. And just let's do a print and say vector stores created. Okay, let me explain that quickly what we are doing here, guys. If you are not familiar with the retrieval part of it, we have imported all the required libraries. We have an embedding model that we are using. It's by LLMWare, by AI blocks. Okay, so I like them. What are they doing, right? Basically, I like people who are working for the open source community to strengthen the open source, right? Because open source will win. That's how the AI, we have seen how AI has evolved, right? We still use BERT, we still use transformers. All these LLMs, even the closed source ones, are based on transformers, which is an open source thing, right? So open source is powerful and we have to make it even more powerful. That's what the people like Jan LeCun and others, they advocate it for, right? So LLMware, the AI blocks or something, if I remember it exactly, they are doing good stuff. Let's back them up so they can build it more LLMs and more embeddings model and the more AI products for us. Now, if I look at here, we have embedding model, we have a directory loader that loads your file, then the documents, loading it, recursive character text splitter. LangChain provides character text splitter, recursive character text splitter, JSON splitter, tick token, etc. Right? So you can use that depending on your use case. I have a chunk size of 700, overlap of 70, then I'm splitting the documents, then I am just creating a vector store, persisting it with a collection metadata. That's what I'm doing. Now let's run this and see Python. Okay, why I'm writing it. It says, okay, LLMware sentence position argument 2 were given. Okay, I forgot to define the model name here, by the way, excuse me, sorry. Model name equal, but this is so bad, it should automatically, when there's a string, it should be model name, right? But I think there are other arguments and quarks as well. That's why I think the error is fine. I think that makes sense. Uh, Now, once you do that, you will see, right? For the first time, it will take a bit of time because it's going to download the model for you from the Hugging Face weights thing. You can see it downloaded for me, transformer, pooling, etc. that they are using, right? And now, once you do that, it says vector stores created. So our vector store has been created, and you can see it over here. It says insurance cosine. It has an SQLite database. 6 months back, Chroma was using DuckDB Parquet, right? DuckDB, they were using it. Then they migrated from DuckDB to SQLite, and that's why you see this new structure of Chroma DB. And then you have your everything here. Okay, your bin files, all the n-dimensional spaces where your vectors are stored, right? With metadata, arguments, etc. Now, your vector store has been created, which is inside this folder, and our ingest is done. Now, once ingest is done, let's create something called retrieve now. So retrieve.py or something. Okay, I'm just going to call this retrieve.py. Now, in retrieve.py, what we are going to do is we're going to retrieve and see if our retriever is working fine. So let me just copy this thing here from ingest, and we'll see what are the things required. Let me just put it here. I don't need this couple of things, all of this. Okay, I don't need it. Okay, I need these two because these are the things that we're gonna use. So I need the embedding model again because once I put a query, that respective embeddings needs to be there, and then we will pass that respective embedding for the query in the vector database or a vector store, and then that will retrieve the similar chunks for you. That's what we're gonna do. Let me just do a load vector store here. A load vector store, and here I'm gonna write chroma. And I'm not doing from documents. You only do from documents when you are creating it. Once you persist on disk, you just have to use chroma, not dot from documents. That's not required. Now inside chroma, what I'm going to do is persist directory. That which directory I'm going to use as a vector store is stores and insurance cosine. Okay, you can look at the folder name there. Let me see that insurance, and then we have your embedding function. Okay, which is your model, by the way. So that's called function here in this class of chroma, and then you pass your embedding thingy. So let me just pass that. Let me do an alt G. This is how now you have loaded your vector store. So once you load your vector store, let's define a query. So I'm gonna use the same query I have here on the notepad, by the way, that I was showing you. Let's just get it, and you can use any other questions from your data, it's fine. Just to save some time, I have just already copied it. Now what I'm gonna do is I'm just saying docs equals load vector store, and it has a method that's called similarity with similarity search with score. So I'm just going to do a similarity search to see if that is working fine. Similarity search with score, and that will basically return me the similarity search with a score. I'm going to define query equals query, which is, and then top k documents equal to 3. So give me 3 documents, and then I'm going to use a for loop for I in docs just to make it more readable. Doc and score equals I. Python is fun, right? I, and then print, and some key value pairs here. So let me just do a score, and score is done. Then content. So content equal, which is nothing but your doc dot page content. Doc dot page content, and then your metadata. So let me just do a metadata thingy here. So metadata. Okay, doc dot, not page metadata, it's only metadata. Okay, so let's just do that. Perfect. Let's see if this works, guys. If this doesn't work, then see that I'm doing something wrong. So let me just do Python retriever, not excuse me. Ah, oof. And it's not retrieve. Okay, it's retrieve on. Let me see if the spelling is right. Trieve. Once I do that, hopefully I'll get something here. Let's see it. I'm expecting that it will generate some response, and you can see, let me just bring it here in the notepad. Okay, so you can read it better. I'll make it bigger, and you can see here. Let me just make it a bit space because we have top 3 documents, and you can find out we got our response. Fantastic. It says most group contracts are sold to business that want to provide life insurance, blah, blah, blah. Group life insurance can be sold to associations to cover their members and lending institutions to cover the amounts of their debtor loans. And this is exactly what we see here in our data. Let me open that and let me show you. It's by group, right? Let's come to G quickly. Okay. Now G or something, and you can see this is what it is, group life insurance. It says blah blah blah. Most group contracts are sold to businesses that want to provide life insurance. You can see members, etc., right? Fantastic. Well, it's working fine. Now the embedding model has done its job, and you can see with a very small embedding model, it's done the job for insurance, understand the taxonomy and the terminologies of insurance industries. Let's go back and write the app.py thingy now. So let me just write an app.py here quickly. In app.py, what I'm going to do is I'm going to copy a lot of things. I don't want to write the same thing again and again. Okay. Now let me go back to my any chatbot. I'll just copy this prompt template, etc. Right? I'll just copy this prompt template from my 25 others rag video that I have. Okay, I'll just copy the prompt template, a simple prompt template, and a few things I will also copy. I'll copy this. Yeah, let's copy this load vector store as well. Exactly, let's copy this too. Okay, and you know what we are doing here. So we are just using a prompt template equals prompt template, input variables, context and question. Then I'm loading the vector store chroma. Let's get it from here quickly and put it here. Then let me just import Streamlit as well. So import Streamlit as st, and then what I'm going to do is next is let me just get this as well. And this I will write in a function. I'll explain that from top to bottom. Let me just write a QA chain. And inside this QA chain, I'm just going to use that. There are some indentation problem. Let me just get it back once, and then I can just do this as well once. Perfectly fine, and just return the QA. Now this is going to be the same, guys. You can see we are whew, okay. Load vector store, and then let me just get a few things quickly from langchain.llms. Now here in the LLMs, I'm going to import Hugging Face hub, right? I'm going to use the hub. I will show you how you can get that inference API. Now, if you look at this model, this is the LLM that we are going to use. It's around 80% lesser in size, and it gives you the same performance, as equivalent performance as 7B models, and that is why I'm using it, because these LLMs are fine-tuned for RAG, guys. So if you want to build a RAG, you can just use this, and you can see it's available through inference endpoint. You can find it out over here. It's also available through TZI, text generation inference. And if you come here on deploy, once you click on this inference API, it also shows you that how you can use it through tokens, so API tokens and blah blah blah, right? Inference API, and that's what I'm using. Okay, here you need a token from Hugging Face settings. You go to your Hugging Face accounts, go to settings. If you don't have an access token, create an access token and just get it. Make sure that access token is readable, read only tokens. The write is not required for this purpose. Now let me do a set page config or something quickly. Okay, set page config for Streamlit. So st.set page config. I'm going to give a page title. Page title equals what would I do? Insurance rag demo. Okay, set page config and st.title. Okay, and insurance rag demo. Now I need a .env thingy as well. So let me just do. I have installed python.env. So from .env import load.env. Ah, load.env. Let's get OS as well, because we have to get env as well. Retrieval QA chain is required. So from langchain.chains import retrieval QA chain. What else we need? I think we are fine with this now. Okay, let me just get this load.env thingy here very quickly. Load.env. Load.env is fine, and then os.invan. And here you have to write the same. Anyway, let me just get it, because anyway I'm going to delete that. Okay, so I'll just copy this variable, come here in app.py, and then just paste this os.getEnv. Perfectly fine. Now this your API has been loaded. Now you have your prompt template set. Now so you can basically increase the complexity in prompt templates to avoid hallucinations or make it more structured, or you can also specify some examples here just to retrieve better. Now you have your prompt. So let's get the embedding first. We need the embedding model. Let's get it from retrieve.py. That's why I've written that function as well. Right now, embedding sentence transformer embeddings model name is okay. Let me just do it more better. Then load vector store chroma. This will not be paid cosine. This is from my previous repository. You have to change to your cosine. So insurance cosine, embedding function embeddings, and then you write your retriever. So retriever equals load vector store. Okay, so load vector store and dot as retriever. So I'm going to use as retriever of LangChain. So as retriever to uh, IEVER as retriever, and here I'm going to pass the search quarks. So search quarks means top K documents and some of the other arguments that you can define. Now here I'm going to just do k equals 2, only look at two top k documents. The retriever is done. Now here you define a repo ID for your model. So let me just do that for the LLM that we are going to use. So this is the LLM by LLMWare. You can see BLING seared llama 1.3 and the first version of the model 0.1 that you see. Now the repo ID is done. Now after repo ID, what you have to do is you have to do LLM equals Hugging Face Hub. So let's do an Hugging Face Hub, and inside this I'm going to pass my repo ID equals repo ID. Then you have your model quarks. So let me just do model quarks, where you can set up your inference parameters. It's not hyperparameters. These are inference parameters that you can set up, like temperature, top p, top k, max new tokens, etc. Okay, and these are the smaller things that you should know, guys. Hyperparameter, you do it once you fine tune or train a model, not once you inference it. Now model quarks, and in the model quarks what I'm going to do is pass a temperature. So let me just do a temperature, and let's keep it 0.3. Its value can be, if you keep it higher, the model will be trying to become more creative, might hallucinate a bit, but it's not strongly associated with hallucinations. I see a lot of people in industry talk about it, right? That okay, your temperature is higher, model hallucinates. It's not like that. It has some role to play, but hallucination is a complex topic. Max length 500. Let's keep it a smaller max length. This model is good for chatbot kind of a thing, where you want a very long detailed response. This model is not for you. This model is for if you want to build a chatbot kind of a thing, or a conversational interface. Now model quarks. Now after that, let's define a chain type quarks, and chain type quarks is nothing but your prompt thingy. So my prompt okay, prompt equal a colon, by the way, that becomes your prompt that you have defined in line number 26. Perfect. Then we have QA chain, guys, and then after that, once you have this QA chain, let me just do a QA equals QA chain, and then we are going to use this QA in our Streamlit code. So let me just write a main function. So define main, and let me also quickly write if underscore underscore name underscore underscore equals, and this is bad, right? You can see it's tab 9 is not suggesting me once I need it. Okay, main underscore underscore and then colon main. Here we go. Okay, now inside this I'm gonna write my all of the thing. The first is text query, which is the text area. So st dot text area, xt dot text area, and here I'm going to write ask your question, and let's give a height to it. So height equals, let's keep it 100. Okay, it's fine. Height equals 100. Then let's have a generate button response kind of a thing. So generate response button, and let's define st dot button generate response, or let's call it run rag, run retrieval augmented generation. Now I'm going to say st dot subheader. Let's already keep a subheader for response, and let's call it response. Whew. Response, and then after that I'm going to say if generate response button and text query, there are value, or the button has been clicked and there's a value inside text query. You can also do with length text query greater than 0, or if text query is not none, you can also do that. I'm going to have a spinner that will spin with st.spinner generating response, blah 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 with st.spinner, and then you just do okay, with a width. Then you write text response equal. Then I'm going to use the QA that we have used above and pass the text query. Here we go, text query, and then say okay, if text response, it's response, it's fine. Okay, you can let me make the change, by the way, because you will be using the same GitHub repository, right? So if text response is st.write, and I'm going to do text response st.success, and here I'm going to do response generated, and then if not, then just give an st.error that hey, I'm not able to generate the response. response not generated. We are done with this, guys. Now let me show what we are doing here very quickly. We have imported all the libraries. We are using Streamlit, so setting the page config, etc., loading the envs, from that env file. Then I have a prompt template. I have a prompt where I use prompt template, define the input variables, couple of variables. One is your context that comes from the retriever part of it, from the vector database, and the other is your question that the user will ask. Both gets combined with your prompt, and then it goes to a large language model to generate a human-like response. That's what it does. Now you have your embeddings. We're using LLMWare embedding, but insurance. Then load vector store chroma. From persist, we are loading it now. Then we are having a retriever thingy as a retriever, search quarks, blah blah blah. And then we are just using an LLM that you can see from Hugging Face Inference API, the seared llama BLING, where no GPU is required. You can also download the model locally and do it through Transformers pipeline. I think you can do that much, right? Which is shown here as well. They have given some code. You can look at here how you can use this code. Okay, this is a detail. You can use Transformer pipeline to do that, right? Auto causal LM, you can use it to do that, etc. Because it's a text generation task. Now you have your QA chain, retrieval QA chain type, defining stuff, QA blah blah blah, Streamlit kind of thing to run that. Let's do it. Okay, let me see if we have imported everything. We have chroma, we have OS, retrieval, prompt template. We do not have a prompt template, so let's get that. So from langchain dot prompt, it's prompts. From langchain dot prompt import prompt template. So this is what the prompt template is. We have our sentence transformer embedding, Hugging Face, retrieval QA. We have chroma. Let's run it now and see if we get any error. Now what I'm going to do is Streamlit run. Streamlit CMD, by the way. Sorry. Streamlit run app. This is once I do Streamlit run app.py, you can see what it says. It says, oh, cannot assign to function call here. Maybe you want mean. Okay, this is instead of this is okay. You can tell me what are the mistakes I have done here. It's not a method, right? I This is my bad. This is my bad. This is my bad. This part is not a thing, which is right. Now it's loaded. Let me just close this man. Okay. Let's do a. Can I do a rerun kind of a thing? Let me see. It gives you something. I don't know if there's still some errors. We'll see it out. For the first time, it will take a bit of time. Let's use the same question quickly, and we can also ask one more question and see if it's working fine or not. Let's use that here, run rack kind of a thing. Once I do it, you can see it's gonna generate some response for you. Okay, you can see it says generating response, and fantastic, right? We are using LLMWare embedding model and LLM, and we get the output here. Query is what is group life insurance, and it give you group life insurance is a type of insurance that is sold to businesses that want to provide life insurance for their employees. Fantastic. This is great. Loved it. Loved the response. Let me ask one more question quickly. What kind of question we can ask? What is inflation protection? Okay. Let me ask this question quickly. What is the inflation protection, and see if it's able to generate some response. And you can try it out for the complex use cases where you see there are chances of hallucinations. You can try it out this model. I also wanted to test this model, and in the first go on a very initial experimentation, I like the model and the embedding model both, which is very lightweight to work with, very easy to deploy as well, right? So let's try it out and see, and let it generate. The code is available on my GitHub repository. You can find it out over here. LLMware RAG demo app. Let me just do one thing. I'll open Streamlit Cloud or something like that. Okay. Streamlit Cloud. Okay. Let's see. Sign in. So slow. Continue with GitHub. Here Streamlit is something that where you can deploy your and you can see we got inflation protection as well. So inflation protection is a type of insurance that pays a lump sum amount of money if the insured insurance policy is cancelled. Insurance company offer, wow, this is fantastic. Great response from 1.3 billion model. I really loved it. I think the credit goes to LLMware and the AI blocks team. I'm more than happy to, see that the future LLMs and the models that they are going to build. Now I'm going to create a new app. Let me see that. Okay. Um, Let me see if I'm able to get something. Okay. What is this file name? Where's this file? Okay. I have imported everything, right? The env is not there, but it's fine. So we have app.py. I'll just show you probably. I'll just not show everything, but this is how you can deploy if you have an Streamlit app. Domain is available now in advanced setting. You can have your secrets. Let me use Python 3.10 and let me use this from env. Okay. I'll just try it out if this works. Otherwise, you have to see it. Okay. Save, deploy. Maybe some requirements also we have to add, but this is how you can deploy an app. Okay, it gives you 1 GB free space to deploy. So if your entire folder is not bigger than 1 GB, of course, LLM saving locally will not help you to deploy like this on free Streamlit cloud, but I am using inference API, so I think I'll be able to deploy it. I'm not sure. Let's check it out and see if that's the case. But if not, then you just got the idea, right? How to deploy. And you can see the app is working fine, and you can find out the deployment over here. You can see it says click on manage app. It's installing everything. The problem is that you have to do a bit of uh, work around here because, for example, you just saw NVIDIA, NCC, and all of those things have been installed. And I think we don't need it, so we should have just said torch CPU. So it would only have installed torch CPU, but it is fine. Anyway, you can deploy your Streamlit app here. Insurance rack. Find the GitHub repository here. I'll give the link in description. Find the models here by LLMWare. Find the embedding model here by LLMWare, and this is the Hugging Face repository of LLMWare. Okay, so this is fantastic GitHub repo, and that's all. You can see it says installing successfully uninstalled. Let's wait for a few couple of minutes and see if it's able to deploy it, because I believe that will exceed more than 1 GB of space, because the embedding model is around 400 MBs, okay, of size. And then you have your all the required dependencies that will again be around, I don't know, 400 500 MBs again, because you have torch, you have sentence transformers, NVIDIA, you install something is not required. But let's see it out. One more minute. And mm, but you can see it says your app is in the oven, right? I love the UX part of it. They would be using some socket programming to get the status from this part of it, that if that gets done, it will load the app. It's a containerized application. They use container to run this. But anyway, it's taking a bit of time, guys. If it gets successful, I will give the link in YouTube description, and if it's not, I will not give it. So please excuse me for that. But the video is one more towards covering LLMware models and embedding models, because few of you also requested it. I could see the comments, and I hope you loved it. I liked it a lot. You can see the performance, fantastic. For chatbots, it's really good, where you need probably not need a longer responses. For that, it is good. That's all for this video, guys. If you have any thoughts, comments, feedbacks, please let me know in the comment box. If you like the video, please hit the like icon. If you like the content I am creating, please share with your friends and to peer, and also subscribe the channel if you haven't subscribed the channel yet. Thank you so much for watching. See you in the next one.